In this lesson we're going to continue to look at redox reactions, but this time in the context of non-metals displacing non-metal ions from their aqueous solutions. So before we have a look at an example, let's just remind ourselves that oxidation involves the loss of electrons. The element loses electrons to have its oxidation state increased, while in the case of reduction it gains electrons and so has its oxidation number decreased. So let's look at that in the context of a displacement reaction. So in this case we've got a solution of potassium bromide, which is a clear transparent solution, and we're going to add chlorine to the solution in the form of chlorine water. That's chlorine dissolved in water, or if you like, if we bubbled chlorine gas through this same solution, then what would happen is we'd form an aqueous solution of potassium chloride, and bromine gas would be released, which would dissolve in the water, forming bromine water. So you get a colour change from a transparent solution to a sort of browny or light browny orange colour due to the presence of the bromine gas. So to understand this displacement reaction in terms of loss or gain of electrons, again we'll look at the ionization equation. Okay, you can see in this case that the bromine ion is being oxidized. That means it's losing an electron to have its oxidation state increased. It's increasing from -1 to 0. So we can say that here oxidation is taking place, while in the case of the chlorine gas, well, the chlorine is gaining an electron to form chlorine ion, so it is being reduced, and so we can say that reduction is taking place here. The bromine ion is being oxidized and the chlorine gas is being reduced. So we say that in this particular reaction the chlorine gas acts as the oxidizing agent, while the bromide ion is acting as a reducing agent. That's to say, it's supplying electrons to the chlorine gas. Okay, so in the same way as we talked about the reducing and oxidizing properties of the metals in their reactivity series, we can also do the same for non-metals. And really, for your Gcse chemistry, you really need to know, the oxidizing powers of the halogens. And as you can see in this table, the oxidizing power increases as you move down group 7 from fluorine to iodine. Okay, so if we had a solution of potassium bromide, we would not expect the bromide ion to be oxidized by iodine, for example, because iodine is below bromine in the reactivity series. Okay, so we would expect no change, no reaction at all between iodine and potassium bromide. There would be no reaction. Whereas, as we've just seen, if we take chlorine gas and add it to potassium bromide solution, well, yes, there will be a reaction because chlorine is above bromine in the reactivity series. Therefore, chlorine is able to oxidize the aqueous bromide ion to form bromine gas. Okay, and there will be a reaction there. Now, there are a couple of other oxidizing agents that I'd like to add to this series so that you can see where they fit in with respect to the oxidizing powers of the halogens. And these are the manganate 7 ion. Okay, in this particular case, manganese has an oxidation state of +7. Oxygen always has an oxidation state of -2. There are 4, so we've got 4 times -2 is -8. That means in this case manganese must have an oxidation number of +7. And the other oxidizing agent is hydrogen peroxide. Okay, so these are more powerful oxidizing agents than chlorine. So, for example, if I had a solution of potassium chloride and I wanted to oxidize the chloride ion, then I wouldn't be able to use either bromine or iodine, as we've just mentioned, because they are below chlorine in the reactivity series. That's to say, they are weaker oxidizing agents. To be able to oxidize the chloride ion, we need a more powerful oxidizing agent. So we could use, in this case, either hydrogen peroxide or the manganate 7 ion, and if we were to add either of these to a solution of potassium chloride, then we would get chlorine gas being given off. So H2O2 or the manganese 7 ion will oxidize the aqueous chloride ion to produce chlorine.